Okay, now, so let's take a look. So for example, lousy line here. For example, we have light traveling from glass to air. You can recall from previous page, the refractive index of glass is 1.5. Refractive index of air is 1.0. So which is denser? Definitely glass. So if my light is traveling from glass, air, right, what's going to happen? The light ray will bend away from the normal. Right? It will bend away from the normal. So this is your I because it's the angle of incidence. This is R, angle of refraction. Now, this is how we can use refractive index to determine whether it bends inwards or bends outwards. However, there's something interesting here. Do you realize that I can actually make my I increase? As my I increase, my R will also increase. Okay? As I increase, R will also increase. But what's the maximum value for R? Realize R will increase until it reaches here. So there will come to a point when my I is like this. Okay, this is my angle of incidence. Glass to air. I is traveling like this, but my light bends so much that it starts to travel along here. Okay, the angle of refraction is 90 degrees. Okay, R is equals to 90 degrees. This is a special case here. Okay, we call this angle, this value of I here. Okay, this I is what we call your critical angle. Okay, so what is this critical angle here? It is actually an angle of incidence by which the angle of refraction is 90 degrees as it travels from a denser medium to a less dense medium. Okay, so just take note, it is an angle of incidence. Okay, it's specific to each medium. Okay, it's specific to each medium. So glass has its own special critical angle, water has its own critical angle, diamond has its own critical angle. It's a fixed value. Right, so it's an angle of incidence whereby the angle of refraction is 90 degrees. Oops. Okay, angle of refraction is 90 degrees when it's traveled from a denser to a less dense medium. So take note, critical angle is an angle of incidence by which the angle of refraction is equal to 90 degrees as it travels from a denser to a less dense medium. Okay, so this is a critical angle. Now, for glass, it has a critical angle of about 41 degrees. Okay, for water, it has a critical angle of about 48 degrees. Now, the last one which I wrote in the previous page is obviously diamond. Okay, so the refractive index for diamond on the previous page, you know that it's actually 2.4. What's the critical angle? The critical angle is about, if I'm not wrong, is about 26 degrees. Okay, the critical angle for diamond is about 26 degrees. So you can see here, as the refractive index increases, right, from 1.33 to 1.5 to 2.4, the critical angle decreases 48, 41 to 26. Okay, so you must be asking me, so what's the point of remembering or learning how to calculate this critical angle? Okay, what's the point of learning? I'll tell you later on. First, you must know how to find all the values we have shown you just now. Okay, we know that the refractive index is equals to sine I over sine R, which I do not like. So let's convert it to the one which I like. There's a sine angle in air divided by the sine angle in medium. Okay, whatever medium that will be. Okay, now, if you look at the previous page, glass to air. Where is the angle refraction? Angle refraction must be in air. So this will also be equivalent to sine 90 divided by sine C. C is known as your critical angle. If you do press your calculator, you realize that sine 90, the value of it is equals to 1. So n is equals to 1 over sine C. And we do some sort of rearrangement. Okay, let's say n is equals to this. We realize that sine C is equals to 1 over n. And this will lead us to having this formula. C is equals to arc sine 1 over n. Okay, so this is how you can calculate your critical angle. So you can try to find the critical angle for water. This is equivalent to sine arc sine 1 over 1.33. Right, you can also find for your glass. There's also sine inverse. You get 1.5. And the last one is of course C of diamond. Right, it's arc sine 1 over 2.4. So these are all the critical angles that you can calculate here. Okay, go and find the value, try it out, use your calculator.